Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0460, signifies that the fuel level sensor, which is also known as the fuel gauge sending unit, is registering out-of-range values. This sensor plays a crucial role in conveying accurate fuel level information to the vehicle's gauge cluster, allowing the driver to monitor fuel availability. Typically located within the fuel tank, the fuel level sensor operates via resistance changes that reflect the fuel level. When this code is triggered, it indicates a potential problem with this sensor or its wiring, affecting the accuracy of the fuel measurement as displayed on the dashboard. Before beginning troubleshooting, it's also important to check for additional codes such as P0462 or P0463, which may shed light on the current fault and must be addressed first. This guide outlines the exact steps necessary for a thorough and effective troubleshooting process. The fuel level sensor, or fuel gauge sending unit, is essential for providing accurate fuel level readings to the driver. Its typical location is within the fuel tank, where it measures the level of fuel based on changes in resistance. This data is then transmitted to the gauge control module. If there are issues with the fuel gauge sending unit or its wiring, the communication between the gauge control module and the sensor can be disrupted, resulting in incorrect fuel level readings. The DTC P0460 indicates that the information being received is out of range, which can mislead a driver regarding how much fuel is in the tank. Therefore, resolving this DTC is critical for ensuring proper vehicle operation and fuel management. Several factors may lead to the triggering of DTC P0460. Firstly, a faulty fuel level sensor itself could cause irregular readings, rendering it inaccurate. Additionally, shorted wiring connections, specifically in the fuel gauge plus wire or the fuel gauge minus wire, may influence the sensor's functionality. Open circuit issues can also arise, potentially disrupting the electrical flow necessary for accurate readings. Another possibility is a malfunction in the gauge control module, which may fail to interpret signals from the fuel sensor correctly. Lastly, corroded or poor connections at terminals can impede communication, leading to the DTC being set off. It's essential to thoroughly check each of these to pinpoint the exact cause. When DTC P0460 is active, drivers typically experience several noticeable symptoms. One primary indicator is inaccuracies in the fuel gauge. The gauge may read full when the tank is nearly empty, or show empty when there is fuel available, thus misleading the driver. Additionally, certain warning lights may illuminate on the dashboard, alerting the driver to potential fuel system issues. In some cases, reduced fuel efficiency might be observed because the engine may not be operating optimally due to fluctuating fuel levels. Unexpected engine behavior can also surface if the system fails to deliver the correct fuel level data, thereby affecting engine performance. Lastly, complete failures in fuel level readings can occur, making it difficult for the driver to determine fuel availability. The first step in troubleshooting DTC P0460 is to verify the existence of the trouble code. Start by turning the vehicle to the on position without starting the engine. This allows the onboard diagnostic system to self-check its various modules. After this, you should clear the DTC using the Honda Diagnostic System, HDS, a specialized tool for Honda vehicles. Once cleared, turn the vehicle off and then switch it back to the on mode again after 30 seconds. This waiting period is crucial as it allows the system to reboot properly. Afterward, check for any pending or confirmed DTCs once more using the HDS. If DTC P0460 reappears, further investigation is necessary. If it does not, you may be dealing with an intermittent failure. In this second step, we focus on checking for shorted wires in the fuel gauge plus line. First, ensure that the vehicle is turned off and in the lock mode for safety reasons. Next, remove the gauge control module located in the dashboard area for better access. Disconnect crucial connectors, including the fuel tank unit's 4P connector and the gauge control module's connector A, 32P. Then, you will need to measure the resistance between two test points. The female terminal number 2 on the fuel tank unit's 4P connector and a solid body ground. It is essential to conduct this measurement under the specified conditions that the vehicle is off and both connectors are unplugged. If the resistance measures 1 megaohm or more, then you can proceed to the next step. If not, it confirms there's a short in the fuel gauge plus wire that must be repaired. The third troubleshooting step involves checking for open wires in the fuel gauge plus line. Initially, remove the jumper wire applied previously and then connect new jumper wires between the fuel tank unit's 4P connector terminal A and body ground. This setup allows you to manipulate the circuit for testing purposes. Measure the resistance between the gauge control module connector A, 32P, terminal number 22, and body ground. Just like the previous step, it's imperative that this measurement is conducted with the fuel tank unit connector and gauge control module connector, both disconnected as specified. If the measured resistance is at or below 1.0 ohms, the circuit is intact, and you should move to the next step. If the resistance is higher, this confirms an open circuit in the fuel gauge plus wire that will require repairs. In this fourth step, we focus on checking for open wires in the fuel gauge line. Start by removing any previously applied jumper wires from the fuel tank unit 4P connector to avoid any confusion during the test. Connect a jumper wire instead between the fuel tank unit's 4P connector terminal A, specifically terminal number 4, and a reliable body ground point. This procedure is necessary to test another essential aspect of the circuit. Measure the resistance between the gauge control module connector A, 32P, terminal number 21, and body ground. Make sure that both connectors remain disconnected as required for accuracy in the test conditions. If the resistance comes in at 1.0 ohms or less, you can confidently proceed to the next step. If the resistance is higher, there is an open circuit in the fuel gauge wire that needs repair. The final troubleshooting step addresses the fuel gauge sending unit's condition. Start by removing any jumper wires connected to the fuel tank unit 4P connector to return to normal operational settings. At this point, you need to test the fuel gauge sending unit for its operational functionality. Utilize the necessary diagnostic tools or visual inspections to determine if the unit operates correctly. If the fuel gauge sending unit is in good condition and sends accurate signals, you will then need to replace the gauge control module since it is likely malfunctioning. However, if the fuel gauge sending unit fails to operate as expected, it should be replaced immediately. Correct diagnostic procedures are crucial at this point, so ensure that the replacements are made accurately to restore functionality. After completing all the troubleshooting steps, it is highly important to verify that the repairs have been effective. Begin this verification by rechecking for the DTC P0460 using the Honda Diagnostic System, HDS. This step will confirm whether the issue has been resolved and no new codes have appeared. Once cleared, you should perform a thorough test drive of the vehicle to ensure that the fuel gauge now provides accurate readings and that the warning lights do not illuminate. A successful test drive without reoccurrence of any codes signifies that repairs are successful. If DTC P0460 or other related codes do appear again, it will require further investigation. Verification is essential to ensure that the vehicle is functioning as intended post-repair. To prevent the recurrence of DTC P0460 and ensure optimal vehicle performance, regular maintenance is critical. Start with periodic inspections of the fuel level sensor and its associated wiring. Checking for loose connections or corrosion can help preemptively catch issues before they affect fuel gauge readings. Additionally, monitoring fuel gauge readings during refueling and vehicle operation can provide clues about any developing problems. Be attentive to any fluctuations in gauge readings that appear abnormal. Should any concerns arise, addressing them immediately can prevent more significant issues down the road. Establishing a routine for monitoring and inspecting the fuel system can save time and resources in the long run. In conclusion, understanding the role of the fuel level sensor is vital for troubleshooting DTC P0460. Through careful examination of potential causes, along with a structured approach using the specific steps provided, mechanics can effectively diagnose and resolve the issue. Following the outlined steps brings clarity to the whole troubleshooting process, ensuring that technicians can address not only the immediate problem, but also any underlying issues related to the fuel gauge system. Regular maintenance serves as a key preventive measure, contributing to long-term reliability and performance. By adhering to these guidelines, vehicle owners and technicians can minimize the occurrence of such DTCs in the future, resulting in a smoother driving experience. Please like and subscribe to the channel. See you next time!